Okay, let's look at question number 4.
Every single day, I'm gonna make something great. That's my way.
Question number 4 describes or is a question about a peak reading voltmeter, which is required to measure voltage up to 150 kV. The peak voltmeter uses an RC circuit, a microammeter, and a capacitance potential divider. The potential divider has a ratio of 1200 to 1, and the microammeter can read up to 10 microamps. You have to determine the value of the resistance, the R and C, if the time constant of RC circuit is 8 seconds. Okay, so this is the question, and the solution is on the next page. Now, before we get to the solution, this is a similar structure of an RC peak reading voltmeter, okay, which uses a diode in this case. So the principle of operation of a peak reading voltmeter is that the AC voltage is applied to be measured, is applied onto these terminals, and then it is rectified, and then that charges the capacitance. Once the capacitance is at peak value, which is the maximum value, then once the capacitance is at maximum value, the diode becomes reverse biased. So once we have the AC changing in terms of direction, then this capacitance now is fully charged, and it will begin its value. The peak value of this capacitance can be reflected as it goes, or as it is measured between this resistance. Okay, and we can, once we measure the voltage between these this resistance, it will be a reflection of the peak value of the voltage across that capacitance, and that gives us the value. So it's the application of voltage division rule that plays a role here, and the principle is that you've got the ratio in terms of the resistance values given in this case as 1 to 1200 to 1. In short, as we are aware, we are using the principle of potential division. Okay, so if I take a resistor and another resistor there, and obviously we can have a microammeter in there, which the current reading will be proportional to a voltage output here, V out, and then you've got your input voltage V in from there. Okay, V in from there. So you've got your R1, R2, and what we've been told is that the ratio between these two elements, okay, is 1200 to 1, meaning that your R1 is equal to 1200 and your R2 is equal to 1. That's the ratio that we're looking at. In terms of that ratio, then it's not the actual values, so it's the ratio. So the ratio of these two elements. If you look at the voltage division principle, our V out will be V in multiplied by the actual procedure here will be R2, which is we are measuring the voltage across that R2, over the sum of R1 plus R2. In the case that we've been given the ratios of what is here and what is there. So the ratios that we've been given is that this ratio is 1, 1, and this is 1200. So our equation then for our output voltage in this case is simply going to be equal to V in 1 over 1200. And what do we have as the input voltage? We've been given that the input voltage is 150 kV, which is 150 multiplied by 1000. That is our V in, and that multiplies by the ratio 1 over 1200, and this gives us 125, approximately 125 volts. So this is the output voltage that is going to be read across this output. And thereafter, since this voltage measured across the output is the same voltage that is across this resistor too, then we are able to determine the resistor value of that voltage, knowing the current in the circuit. The current has been given that the microammeter can read up to 10 microamps. So therefore, if we move further, we are saying since the voltage across the resistance is the same, so VR2 is equal to 125 volts, which we just found, volts. Therefore, the value of the resistor now itself in the circuit is going to be, according to Ohm's law, V over I, which gives us 125 over the current, which is 10 times 10 to the power negative 6, that's 10 microamps. And this is going to give us the value to be 12.5 mega ohms. Okay, and then also utilizing this resistance value, we know that we've been told that we have got the RC constant time. If time is constant in the RC circuit, which is 8 seconds, so we can utilize that now to determine the capacitance in the circuit using that time over the resistance that we've been given. So we've got our T over R here. So our T over R, we've got 8 seconds over the resistance is 12.5 times 10 to the power, so it is mega, that is 10 to the power 6. And that, our friends, gives us the capacitance value of 0.64 microfarads. And that's how we determine these two important variables in a peak reading voltmeter. And that's how a peak reading voltmeter operates. So we come back, this is how we get our solution. So we get our resistance value here, that is R is got 12.5 mega ohms, and then the time constant of the RC is 8 seconds, so we utilize that to determine the capacitance value, and we have the solution. Okay, thank you for your attention. That is how we work on the peak reading voltmeter question.
My dear friends, thank you for watching this channel. Subscribe to the channel for more. Thank you. Have a good one.